2 jugs of lemonade. One has 3 lemons, the other has 4. Which one tastes more lemony? If you said the one with 4, careful, that is a trap. And by the end of this video, you will see right through it. You will also split any bill, any mix, any share in a ratio, all in your head. Here is the secret. A ratio is just a percentage wearing a disguise. Same idea, brand new costume. I am Sweta. This is Code Craft. And today, we meet the secret twin of percentages. 6 quick skills, then you practice. Hit subscribe so you do not miss part 2. Let's start with what a ratio really is, because once this clicks, everything else falls into place. Say you and a friend split a chocolate bar of 5 squares, 3 for you, 2 for them. We write that 3 to 2. That is a ratio. It is simply a comparison, how your share stacks up against theirs. First, a quick warning. Order matters. 3 to 2 means 3 for you and 2 for them. Flip it to 2 to 3 and you have swapped the shares. Always read a ratio in the order it is written. Now, here is the part nobody tells you. Add the parts. 3 plus 2 is 5, so the whole bar is 5 parts. Your share is 3 out of 5, and 3 out of 5 is 60%. Your friend's 2 out of 5 is 40%. Look at that. The ratio 3 to 2 and the split 60-40 are the exact same thing. One written in parts, the other in percent. That is why I call ratios the secret twin of percentages. Next, a ratio has no movements. 3 to 2 is not 3 roofs or 3 liters. It is pure comparison, and that means you can scale it freely. 3 to 2 is the same as 30 to 20 or 300 to 200. Multiply or divide both sides by the same number, and the ratio does not change. Which brings us to simplifying. 6 to 4 looks different, but divide both by 2, and it is really 3 to 2. The same bar, just cut into bigger pieces. Always shrink a ratio to its simplest form first. And one last exam trap. To compare two things as a ratio, they must be in the same unit. 1 meter to 50 centimeters is not 1 to 50. Turn the meter into 100 centimeters first. Now it is 100 to 50, which is 2 to 1. Same unit first, then simplify. So if a ratio is just parts of a whole, then sharing something out becomes easy. Watch. Split 500 rupees between 2 people in the ratio 3 to 2. Do not panic. First, count the parts. 3 plus 2 is 5. Now pour the 500 evenly into those 5 pots. 500 divided by 5 is 100. So each pot is worth 100 rupees. The first person gets 3 parts. That is 300. The second gets 2 parts. That is 200. And here is a habit that will save you in the exam. Check it. 300 plus 200 is 500. The shares add right back to the total. If they do not, you slip somewhere. So the method is 3 simple moves. Add the parts. 1 part equals the total divided by the sum. Then scale each share up. Add, divide, scale. Now, let us prove it works for more than 2 people. Divide 1,200 rupees among 3 friends in the ratio 1 to 2 to 3. Add the parts. 1 plus 2 plus 3 is 6. 1 part is 1,200 over 6. That is 200, ma'am. So the shares are 200, 400, and 600. Check. 200 plus 400 plus 600 is 1,200. Perfect. Same 3 moves. Any number of people. Add, divide, scale. You just split money in your head. Now, that idea of 1 part is secretly the most powerful move in all of ratios. Let us give it its own spotlight. Here is a classic. 3 notebooks cost 120 rupees. What do 7 cost? Most people freeze. But you already know the trick. Find 1 first. 1 notebook is 120 divided by 3. That is 40 rupees. Now 7 notebooks. 40 times 7 is 280. That is the unitary method. Find 1, then scale. Let us do 1 more, so it truly sticks. If 5 identical chairs weigh 40 kilograms, what do 8 weigh? Find 1. 40 over 5 is 8 kilograms each. 8 shares, 8 times 8 is 64 kilograms. Find one, then scale every single time. Now, exams love to dress this up as a proportion. 3 is to 120 as 7 is to what? When two ratios are set equal like this, there is a shortcut. Cross multiply. 3 times the unknown equals 120 times 7. The two diagonals must balance. Like a seesaw, solve it and you get the same 280. Just keep the order consistent. Notebooks on top, rupees on the bottom, on both sides, and one little gem for the tough papers. The mean proportional. If 4 is to x as x is to 9, then x sits right in the middle. It is the square root of 4 times 9, which is 6, the geometric middle of the two numbers. So, find one part, keep the ratio equal, and scaling will never scare you again. Alright, remember those two jugs from the start? Time to settle it. Jug A has 3 lemons and 5 cups of water. Jug B has 4 lemons and 7 cups of water. Your gut screams B. 4 lemons beats 3. More lemony, right? Let us test it the twin way. In Ju A, how much of the drink is lemon? 3 lemons out of 8 cups in total. 3/8 and 3/8. Remember from part 2 is 37.5%. Now Ju B 4 lemons out of 11. That is about 36%. Look again. Jug A is stronger. The one whose fewer lemons wins. Because it is not how many lemons. It is the share of lemon in the whole drink. Now the fast way, no percentages needed. Compare 3 to 5 against 4 to 7. Cross multiply. 3 times 7 is 21. 4 times 5 is 20. 21 beats 20. So 3 to 5 is the stronger mix. And notice, the percentage way and the cross multiply way gave the exact same answer. They are the same twin. Once again, let us lock it in with one more. Compare 5 to 9 against 6 to 11. Cross multiply. 5 times 11 is 55. 6 times 9 is 54. 55 wins. So 5 to 9 is the stronger mix. Even though 6 and 11 are the bigger numbers. Say it with me. Bigger numbers do not mean a bigger share. That is the lemonade trap, and now you will never fall for it. Exams love to chain ratios together, and this one trips everyone. Suppose A to B is 2 to 3, and B to C is 4 to 5. Quick, what is A to B to C? You cannot just line them up, and here is why. Look at B. In the first ratio, B is 3 units. In the second, B is 4 units. Same person, 2 different sizes. That makes no sense. B has to be one single value. So we fix B. We make both B's match. The smallest number that both 3 and 4 divide into is 12. So scale the first ratio up by 4. 2 to 3 becomes 8 to 12. Scale the second up by 3. 4 to 5 becomes 12 to 15. Now B is 12 in both. They line up. Read straight across. A to B to C is 8 to 12 to 15. That is it. Match the middle. Then read across. Let us feel why this works. All we did was rewrite each ratio in an equal form, the same trick from the very first lesson. We did not change either relationship. We just expressed them in a common size for B, so they could join hands. And it does not stop at 3. If a fourth ratio arrives, say C to D, you do the same thing again. Match C this time, and the whole chain lines up. So, whenever two ratios share a link, make that shared link equal first. Then, just read across. Last one, and it is the sneakiest of them all. Here are 2 bars in the ratio 2 to 3. Now I add the same amount, 2 to each. 2 becomes 4, 3 becomes 5. New ratio, 4 to 5. Fair, right? I added equally to both, so surely the ratio is unchanged? No. 2 to 3 is 0.67. 4 to 5 is 0.8. It changed. And here is the feeling behind it. That plus 2 landed on a small bar and a big bar. On the 2, adding 2 doubled it. A 100% jump. On the 3, that very same 2 is only a 2/3 jump. The little one grew faster, so it caught up. A ratio is about multiplying, not adding. The only way to keep 2 to 3 the same is to multiply both by the same number. 2 to 3, 4 to 6, 6 to 9. Every one of those is the identical ratio. Now watch how exams weaponize this. The ratio of two numbers is 3 to 5. Add 4 to each, and it becomes 5 to 7. What were the original numbers? Because adding shifts a ratio in one fixed way. Only one pair can fit, and you can find it by scaling. Try 3 and 5. Add 4, you get 7 and 9. Not 5 to 7. Try 6 and 10. Add 4. You get 10 and 14, which simplifies to 5 to 7. There it is. The numbers were 6 and 10. So remember, an equal amount added to unequal sizes never lands equally. It is the same twin idea from part 2. The second percent writing a bigger base. For keep a ratio, you multiply, you never add. Alright, your turn now. The streak counter is ready. Let us light it up. Easy one first. Share 700 rupees in the ratio 3 to 4. Pause and try. Add the parts. 3 plus 4 is 7. One part is 700 over 7. That is 100. So 300 and 400. If you used add, divide, scale, that is a green tick. Medium. 4 pens cost 60 rupees. What do 9 pens cost? Pause. Find 1. 60 over 4 is 15. 9 pens. 15 times 9 is 135 rupees. Both level. Which juice is more lemony? 2 to 5 or 3 to 7? Pause. Cross multiply. 2 times 7 is 14. 3 times 5 is 15. 15 wins. So 3 to 7 has a stronger mix. 3 for 3. You're on fire. Boss round. The tricky methods. Ready? Easy. Simplify the ratio 45 to 75. Pause. Both divide by 15. That is 3 to 5. Clean. Medium, a chain. A to B is 3 to 4. B to C is 6 to 5. Find A to C. Pause. Match the middle. B is 4 and 6. Both go into 12. The first becomes 9 to 12. The second becomes 12 to 10. So A to C is 9 to 10. And now the real boss. The ratio of two numbers is 2 to 3. Add that 6 to each, and it becomes 4 to 5. Find the numbers. Pause. This is a proper exam question. Remember, adding shifts a ratio in one fixed way, so only one pair fits. Scale and test. Try 6 and 9. Add 6 to each. You get 12 and 15. And 12 to 15 is 4 to 5. There it is. The numbers were 6 and 9. If you crack that, you have mastered the trap. One last challenge. A real exam style one. Mix everything together. Two friends start a business. They invest in the ratio of 3 to 2. At the end of the year, the profit is 40,000 rupees split in that same ratio. How much does each friend get? Pause and give it a real go. Add the parts. 3 plus 2 is 5. One part is 40,000 over 5. That is 8,000. The first friend gets 3 parts, 24,000. The second gets 2 parts, 16,000. And notice that is a 60-40 split. The twin again. If you solve that in your head, you did not just learn ratios, you own them. Look how far you came. You can now see the twin. A ratio is just a percentage, written in parts. You can share any whole, add, divide, scale. You can compare two ratios without falling for bigger numbers. You can chain ratios by matching the middle. And you know, the ratio multiplies. It never adds. That is the complete toolkit. Next up, Retios Part 2. Ages, mixtures, and partnership, where these very skills solve the real exam monsters. If this made ratios finally click, smash that like button and subscribe. I am Swetha from Codecraft. See you in Part 2.